I'm Mr. Joseph, your chemistry teacher. You're still on mole concept. So the question before us is an advanced stage of what we've done in the past. It's an advanced stage of the previous questions we solved in the past. And this question before us is a little bit time consuming, but it's very simple. But it's going to take our time because we have to write down the proper equation and we have to balance the equation. So it's very, very important that we listen attentively so that we can do the right thing and get the right answer. So let's go. The reaction is between aluminum powder and anhydrous barium nitrate is used as a propellant in some fireworks. I'm just reading the question. The metal oxides and nitrogen are the only products that is a clue. So I want you to pay attention to that. The metal oxide and nitrogen are the only products. Which volume of nitrogen measured under room conditions is produced when 0.783 gram anhydrous nitrate react with an excess of what? Aluminium. So we are dealing with what? Aluminium, barium nitrate, and nitrogen. Those are the only components we're interested in. So the first thing we're going to do is that we're going to write down the equation. So let's go. It says aluminum powder. So this aluminum, solid aluminum powder plus barium nitrate. We should write the proper formula. And nitrate. It's used as the propellant of fireworks. So the metal oxide and nitrogen are the only products. So what are the metals here? Aluminium. So aluminum oxide is one of the products. Solid. The other one is for barium oxide. And nitrogen. So nitrogen, the gas. So this is the equation. That's the first thing. So let's look at the equation properly. Now if you look at the equation, you discover that it's not balanced. You know, when an equation is balanced, the number of atoms of each of the reactants must be equal to the number of atoms of each of the products. So aluminum on the reactant, the number of atoms of aluminum in the reactant will be equal to the number of atoms of aluminum in the product. The number of atoms of barium on the reactant will be equal to the number of atoms of barium on the product. The number of atoms of nitrogen in the reactant will be equal to the number of atoms of nitrogen in the product. The number of atoms of oxygen will be equal to the number of oxygen on both sides. That's when the equation is balanced. So the other challenge is for us to balance the equation, and that's what we're going to do. We have to balance the equation. So now let's balance the equation. So we'll look at aluminum. Aluminum is 1 year, aluminum is 2 year. Barium is 1 year, barium is 1. Nitrogen is 2 year, nitrogen is 2. Oxygen is 6 year, and oxygen is just 4 years. So what do we do now to balance it? Then we now look at both sides. We now add, let's say I add 3 year. So nitrogen will now be 6. But nitrogen is what? Only 2 here. So what do I need to do to nitrogen now? I have to add 3 here. So nitrogen will be balanced. So nitrogen is 6 here. Nitrogen is 6 here. Now the next thing we look at is oxygen. Oxygen is 18 here. But oxygen is just 4 here. So what I do, I'll put 5 here. So oxygen will now be 15. Then I'll now put 3 here. Oxygen will be 18. So 5 times 3, 15, plus 3, 18. Oxygen is 18. Oxygen is balanced now. Barium is 3 here, barium is 3 here, balanced. The only thing that's not balanced is aluminum. Aluminum is 10 here, so we'll put 10 here. So the equation is balanced. Fantastic, the equation is balanced. Now, so if you look at the equation, it is balanced. Now the next step to take is which volume of nitrogen measured under room condition is produced when 0.783 gram of what? Anhydrous barium nitrate react with an excess of what? Aluminium. Remember, I told you that 1 mole of any gas occupies a volume of what? 24 dm cube. So we want to calculate the volume of nitrogen. And here we have 3 moles of nitrogen. So it's going to be 3 times 24 dn³ of nitrogen, which is 72 dn³ of nitrogen. So we're going to focus on what we are given. So we are dealing with barium nitrate and what? Nitrogen. So those are the things we are dealing with: barium nitrate and nitrogen. So using our mole to volume ratio, using our mole to volume method, so we are going to calculate what? The mass of what? 3 moles of barium nitrate. That's what we're going to do. So it will now be 3 bracket. Barium is what? The relative atomic mass of barium is 137.3 plus 2 brackets. Nitrogen is what? 14 plus oxygen is 16. So 3 times 16 is what? 48. Produces what? 3 times 24 dn³ of nitrogen. Because 1 mole of nitrogen requires volume of 24 dn³. So 3 moles will be now equal to 3 times what? 24 dn³ of nitrogen. So let's pick our calculator and calculate the mass of 3 moles of barium nitrate, which is, so I have to use my calculator now. So it's equal to 783.9 grams of barium nitrate generates what? 72 dn³ of nitrogen. So we are asked which volume of nitrogen is produced when 0.783 grams of anhydrous barium nitrate reacts with an excess of nitrogen. So therefore 0.783 grams of barium nitrate will generate what volume? So what we need to do here is to cross multiply. So it will now be 0.783 times 72 divided by x will now be equal to 0.783 times 72 divided by 783.9, which will now be equal to 0.07191 dm³ but our answer is in cm³. So what do we have to do here is to what? Convert dm³ to what? cm³. So we all know that 1 dn³ is equal to 1000 cm³. So 0.07191 dn³ we have to multiply it by what? 1000 to convert it to cm³. So you multiply it by what? 1000, which will now be equal to 0. So you now have 71.9 cm3, which is approximately what? 72 cm3. So the answer to this question is what? B, which is 72 cm3. It's as simple as ABC. Just write down the equation, balance the equation, and use the previous method we use. You can use mole volume ratio also, which is the second method, of which I'm going to use the second method to get it. So please, I want us to look at it very, very well before I use the other method. Irrespective of the method I will use, we still get the same answer. So just pay attention to detail. Whichever way you're comfortable with, please feel free to use it. Very good. Now let's go to the second method. I'm going to wipe off this. So if I were to use the second method, the first thing we have to do, we have to calculate the number of moles of 0.783 gram of anhydrous barium nitrate. So number of moles equal to what? Mass over what? Molar mass. So the mass is what? 0.783. The molar mass is the mass of 1 mole of barium nitrate. So let's calculate the molar mass of barium nitrate. Barium is 137.3 plus 2 bracket. Nitrogen is 14 plus oxygen is 16. So 3 times 16 will give us 48. Which will now be equal to. So let me just use my calculator. Plus 137.3. So the molar mass is 6261.3. So it will now over 261.3. So we now have 0.783 divided by 261.3. So it will now be equal to 2.9. Okay. It will now be equal to 0. 0.00299 moles of barium nitrate. So now look at the equation. From the equation, 3 moles of barium nitrate generates what? 72 dn cube of nitrogen. Therefore, 0.00299 moles of barium nitrate will generate what? X. So cross multiply. So it will now be 0.00299 multiplied by 72 divided by 3. So you get 0.07191 dm cube. So to convert it to cm cube, multiply by 1000, which will now be equal to 71.9, which is approximately what? 72 dm cube. 72 cm cube, I mean to say. 72 cm cube. So the answer is B. The answer is B, which is 72 cm cube. So you can see, irrespective of the method, you still arrive at the same answer. So please, I encourage you to solve as many questions as possible. It's as simple as what? As ABC, and I believe we've really done justice to this topic, more concept. So please feel free to ask your questions. Feel free to reach out to me if there's any difficulty, if there's any challenge. I'm always there for you. I'm Mr. Joseph, your chemistry teacher, so you can reach out to me any day, anytime. So please, I want you to watch the video. I want you to subscribe. I want you to comment. Always be there to listen to you any day, anytime. Thank you very much.